Hi everyone. Let's solve question number 49. Let S equals to this set 1, 2, 3, 4, 5 till 100. And we have to find the number of non-empty subsets T of S such that the product of numbers in T is even, right? So basically we have this T subset and it has various numbers over here. Now we have been given one condition that the product of numbers inside the subset that should be even. So that can be possible in multiple ways. Either one is even and the remainings are odd, or we can have one and the second one as even and the remaining ones are odd, or you can have multiple cases where we have different number of elements inside the subset. We can have just one case, one element, so that would be even. We can have two elements, one is even, one is odd, or both are even. So we can clearly see that we are going to have multiple cases, and not even multiple, numerous cases, very huge number of cases. So that is not possible to do manually, right? So we have to think in the counterintuitive manner. So what I'll do, I'll find out the number of subsets where the product of numbers is odd, and those numbers would be quite finite. Why? Because and easy to calculate, because in case of we have to in case we have to form a set where the product of numbers is odd, then all numbers have to be odd. There should be zero numbers in the subset which is even, right? All numbers have to be odd, and that is why they are easier to count. There are no cases over there. So how to form the subsets which are having just the odd numbers? So let's write one set S dash equals to 1, 3, 5, 7, 9 till 99. I just made a different set with all the numbers as odd numbers. Now, if I try to find out the subset of this particular set, these particular subsets would also be counted in the subsets of S, right? Why? Because these numbers are a subset of this basically this S dash is a subset of S. And if this is a subset of S, so all the subsets of S dash would also be subset of T, right? So number of proper subsets over here, that would be 2 raised power 50 minus 1, because we don't want empty subsets. And in this case, we'll be having proper subsets as 2 raised power 100 minus 1. And if I subtract both of them, I'll be getting the number of subsets where the product of numbers inside them is even, right? Because these were the subsets where the product of numbers inside them were odd. Okay. So if I do the subtraction, I'll be getting 2 raised power 50, 2 raised power 50 minus 1. So A is my correct option.